Antimatter has been detected on the International Space Station, and it could reveal new physics. 8 years ago, the International Space Station detected weird antimatter particles that challenge our entire understanding of physics. Now researchers have proposed that mysterious cosmic fireballs, quote unquote, could help explain the detection. Antimatter particles detected on the ISS may be evidence for unknown physics, new research suggests. The particles, antimatter versions of helium nuclei, may have been produced by cosmic fireballs, and physicists cannot explain how these fireballs formed under the Standard Model, the theory which describes the zoo of subatomic particles. All elementary particles have corresponding antiparticles with opposite electric charges, which annihilate each other on contact. Theory suggests half the matter in the universe should have been antimatter, which would mean the universe would have destroyed itself soon after the Big Bang. And yet antimatter in the universe is scarce and fleeting. While particle accelerators can generate antiparticles through collision of protons and electrons, the special detectors observe antiparticles from high-energy source space collisions, such as those from supernova explosions, and they usually yield only single antiparticles like positrons, anti-electrons, and antiprotons. However, about 8 years ago, the alpha magnetic spectrometer AMS-02 aboard the ISS detected around 10 antihelium nuclei. These nuclei consisted of 2 antiprotons and either 1 or 2 antineutrons. If confirmed through further analysis, the discovery would challenge the Standard Model of particle physics. According to the Standard Model, making antihelium-4 requires that at least 3 or 4 antiprotons and antineutrons be near enough to each other and be moving slowly enough to stick together. Study co-author Michael Fedrick, postdoctoral researcher at Perimeter Institute for Theoretical Physics in Canada, said, based on these requirements, 1 antihelium-4 would be produced for every 10,000 antihelium-3. The really interesting thing about AMS-02 candidate events is that the data seem to be consistent with about 1 antihelium-4 event for every 2 or 3 antihelium-3 events, Frederick said. And that's far above what the Standard Model predicts. In the new study published June 21st in journal Physical Review D, the team tried to explain this discrepancy using hypothetical objects called fireballs. These fireballs could result from currently unobserved phenomena, such as the collision of extremely dense clumps of dark matter, a mysterious substance that makes up about 80% of the universe's matter but does not interact with light, so cannot be directly observed. A fireball is a dense energetic region of space containing large numbers of antiparticles, study co-author Anube Mathur, doctoral student at Johns Hopkins University, said. Once formed, it expands at close to the speed of light, releasing antiprotons, antineutrons, and antihelium into the surrounding environment. The antinuclei subsequently travel outward, and some of them reach the Earth where they can be detected. The researchers modeled fireballs of various sizes and behavior. They found that if the fireballs were large, composite objects made of many dark matter particles, then the amount of antihelium nuclei they produce matches well with the preliminary results detected aboard the ISS, Frederick said. While these findings are promising, they are still preliminary and require further validation. Follow-up studies will help determine if their hypothesis is correct. On the observational side, we're looking forward to the MS-02 on ISS completing their analysis of their candidate antihelium events, as well as to them taking more data in future which may shed further light on this puzzle, Frederick said. The General Antiparticle Spectrometer GAPS project, which will launch a balloon over Antarctica later this year to detect antimatter cosmic rays, including anti-helium nuclei, could also shed light on the matter, Frederick said. This is by Andre Feldman on Life Science. Please leave your comments and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.